by going out of the room, walking around and figuring out how you're going to quantify unusual if we don't want to use the average. I'm with Riley. I think it looks too skewed too to talk about an average, so I'm gonna let it go.
Do we use the median then?
We could, if that were commonly done. We could totally use the median. What would you, so Aaron's saying use the median instead. If we scroll down to what the median is, we're looking at a 70-inch median, which is pretty close to the average. Did anybody calculate the skew coefficient to see if it was skewed enough to worry about? Nobody did, that's okay. Did anybody do, exactly. And I take it from that not a lot of people did the variation quiz for this week, and that's okay. Did anybody do the variation quiz this week? The one with the blue curve on it? Oh, you wanted to, I'm sorry, Haley. So I know you did, I'm not saying you had to, I'm asking if anybody did. So if you did, or if you looked at it, there's actually a measure called skew. It's a mathematical measure called skew, where you can compare, there it is right there, it's called Pearson's second skew coefficient. It's a wonderful little calculation, where you subtract the median and the average from each other to see how far apart they are, and then divide by the standard deviation. Believe it or not, the skew of this curve is not quantifiably all that big. Even though it looks big to me, it looks big to you, that's why we're going to back off of it. But if you actually look at the median is 70. The average was about 71, that's 1 inch, right? And the standard deviation comes in at about 2 inches. When you divide all that, it's about a 0.5 skew, which according to reference, and I'm not going to get too far into this because then you're going to question the reference, as well you should, it's not that skewed. However, back to Aaron's question, how could we use the median? The median is 70. So 70 is here. Now you knew the median was going to be further here than here. You knew that, right? Because you knew the pizza box analogy doesn't apply to the median. It only applies to the average. It only applies to balance on the plate of cookies. The median is the chop, 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 and getting back to the middle. So there's your median. And the mode for that matter. The tallest and the medianist. How do we use it if you want to use the median? What do you think? That's the mode. And one way of looking at it is just pure looking at the mode, Sandy. I got no problem with that. I got no problem with that. However, rather than, it's kind of like the one that Ron was talking about before. It's a metric that's not used very often. And I'd rather not teach you the ones that aren't used very often. I'd rather teach you the ones that are used more often. Does that make sense? So to facilitate tying in the median, because the median is tangentially a part of this, go back to your TIs and let's put what's called a modified box plot on top of this histogram. You did one of these on Monday if you did 18 and 19 on the quiz, which some of you might not have done. That's okay. So let's do this. Back into second y equals. Turn plot 2 on. As far as a type for plot 2, turn this guy on right here. Turn him on right there.
And it should still be L2.
Yes, ma'am. It should definitely be L1, L2 as far as the data, because your data is in the same place. You're looking at the same data set 2 different ways.
So X list would be L1.
X list will be L1, frequency is L2. As far as the mark, you pick whatever you want. I personally like the most obvious mark, which is a big square. That's what I like. This is going to give you what's called a modified box plot. What is a box plot? Do you remember what a box plot is?
The box and whisker.
Box and whisker, got it, Haley. The box and whisker, what is it showing you, Alicia?
The 5-point data, or the 5.
The 5-number summary?
Yeah.
Quartile, good. It shows you the quartiles, all three. It shows you Q1, Q2, and Q3 in the box. So the median's in the middle of the box, Q1 and Q3, and then the end points or the min and the max. When you modify, thank you for that, guys, perfect. When you modify the box plot, it identifies outliers and marks them if there are any. So let's take a look. Do we have it?
Yes.
Yeah.
Aha! According to the modified box plot, we have one. I'm going to finagle my window a smidge. Can I hate to erase these words. You know what? I won't. I'll just slide this forward. I want to get the graph off of your guys' words. Oh, that's much better. Oh! Let's finagle the window, because I don't like the fact the box plot is actually living on top of the histogram. So what I'm going to do is, this is something we don't usually do. I'm going to press window. And I'm going to bump Y max up a little bit. I'm going to put it back to 10.
10?
I'm going to make it bigger. Oh. Here's why, Silviano. If I make it 3, it's going to make it even worse with the box plot on top. I'm going to make it bigger, so I'm going to make it 10. Oops. What is it graphing right now?
10.
Hang on. That's what it's graphing right now. Sorry. 105 stuff. So I'm gonna make the x max 10. There.
Hey.
Now I've got a box plot sitting above the histogram. And now, what's the matter, Haley?
I don't know.
Not behaving?
No.
You guys, I'm gonna figure out what's going on with Haley's. You guys press the trace button. Bump up until you get on the box plot. Oops, where did I go? I lost my graph. Trace up. Now scroll around and watch the numbers at the bottom and what they're telling you. Okay? Take a look.
Look at that.
Yeah, pretty slick.
I need
Huh?
70.
What you got, my friend? Pick graph. Let me see where you're at. Window range. Let's go take a look at oh, your mid is 68. Your max is 10. That can't be. It can't be that. This has to be larger than that. So let's make it. Here we go. You changed. I know what it was. You changed your X max to 10, not your Y max.
Oh.
That's what it was. So your X min was actually bigger than your X max, which confuses the TI.
Got it.
Doesn't like
Which
that.
can't work.
That's only because of the window width. You've got a little more range here than I do. So
It sounds like.
Well, it's my own fault for not having
One
it.
and two.
no, it's okay, Hale. We'll figure it out. So yours is 80, right? So now we look the same, don't we? Yeah, and that's Riley brought up a really, really good point. Your graph might not look exactly the same as mine. Hers looked more like this. Mine looked more like this. So you see how my bars are wider than her bars? It doesn't matter. It doesn't matter as long as we're looking at the same general shape. The key really is we see 0. See the x-axis right there? We see 0, right? I'm pointing at the wrong thing. We see, you see it right here? We see 0 right here, which means we have a 0 reference we're building off of. So when you see 1 and 5, that's 5 times bigger than that. That's the important thing. That's the important thing. Good! So now my question is, see, you identified everything, right? You got your min value. You got your Q1. Thank you, Randall, for this, the Q1, right? We got the Q2 or the median. You got your Q3. Now, here's where it gets interesting. If you were to create a non-modified box plot, it would, you know what, let's not do this. I'm going to turn mine on a non-modified. Just for a second. There, it looks like that. Which means your max is out here. Yes? So what does the modified do?
It separates the outlier.
Good. Next question is, of course, why is it? We know now that when you go to your trace, it tells you right there, it says x equals 75. Notice it's not calling it the max. It's just calling it x, because that isn't the max anymore. But what that 75 is what the TI is considering.
Part of the data.
Say that again.
Part of the data, not an outlier.
And put one word in front of the word. Oh, you said it. You know what? By saying not an outlier, you said it, Haley. Part of the typical data, right? Not an outlier. It's one of the. It's put a line in the sand somewhere out here that says anything bigger than that line is too big.
So he becomes the average data?
So now he becomes part of the typical data. Yes. See, we've been wrestling with this. What does typical mean, right? So the TI has obviously thrown up a line in the sand and said, that's atypical. My question to you is, how did it do it? Now you have to think back to yesterday. Randall, do you remember? Remember what I was doing at the very end of class yesterday? Of course you can say no. Yeah, Alicia remembers. Fingers on the box plots. Remember this what I did yesterday? What I did was I went up here. I'm going to take these out for a second. Let's take this out too, because we'll see it in a second. Now this is going to be rough and ready. We'll get a more precise one here in a minute. Where did I put my fingers? On the box.
On the box.
Q1 to Q3. This is called the interquartile range. Remember what I did with it?
Double it.
I increased the 50% in. So I took that width, made it 50% bigger. So now it's 150% of what it was. And then I put it where?
Both sides.
I went like this with it first. Anything that side of my right finger is too big. You see it out there now? So the line in the sand is right about here.
Why?
Good. Why? I have no good answer for that. Because it's used. Because it... Why do you have on the right side of the room?
Because we intercepted.
Because if we don't, we're going to cause an accident, right?
Why do you use 50% of it, not just
I have no good answer for that, Riley. I'm only telling you this is what is done in practice. No, Riley's got the best question of why 50%? Why not 75%? Why not 100%? Why not 300%? Which is a great question because that was used up until about 10 years ago, and then they started on the one. Riley, I got no good answer for you. I really don't. I wish I had a better answer. It's convention. I wish I had a better answer. And starting Monday, when we start rolling dice in class and collecting purely random data, we don't have to worry about convention because the data presents itself to us in its own way. I'm just saying this is what is done. Wish I had a better answer for you than that, but I don't. So, this method number 2, I call it an IQR method. So there's outlier method number 1, or metric number 1. Number 2 is an IQR method. Now, what I'm going to do is I'm going to write this in mathematical symbols for you. I'm going to write it in mathematical symbols for you because it's more concise that way. It's more concise that way. Do you know how when we created 2 standard deviations or 1 standard deviation or 3 standard deviations around data, we wrote an interval? Let's do it that way because clearly it's going to be an interval. It's going to be a high value and a low value. The high value, and this is going to look a little bit weird. The high value is Q3 plus 1.5 times the IQR. That's a lot of math to hit you with 11:22 in the morning.
Plus?
Good, yes. See, ask me that. Corey, was that you? Who asked me why plus? Davison, the reason why. That's IQR.
Gotcha.
That's 1.5 IQR. That's Q3 plus 1.5 IQR.
It's positive. Like,
Yes!
it's not in the negative.
It's going, now, the other end can go to the negative, Sandy. Thank you for that. The other end can go negative. It won't in our data set. We'll calculate it in a second. We'll calculate it in a second. The other end would be, see if you can figure it out. See if you can figure out what it's going to be. Ron, hold that question. Just give me 2 minutes, tops.
It's not a question.
No, hold it. IQR times 1.5. So we still got 1.5 IQRs. So what would that be like? Q1 minus 1.5 IQRs. Does that make sense? Was that going to be your question, Riley? Oh, damn, well you did. Thank you, sister. We got two birds, one stone. Even though as a former vegetarian, I hate that phrase. But anyway, whatever. You got it. So that's what the other line in the sand would be. Notice how we don't have any down there. Nobody guessed, well, how tall would that have been? How tall of a guess would that have had to have been too small? Can we figure that number out? Of course we can. What's Q1 for our data? It's right there. It is 69. So 69 minus 1.5 IQRs. Let's figure it out. The IQR is the distance between 69 and 71.5. That's 2.5 inches, yes? 2.5 inches increased by 50% is going to be 3.75 inches. Did I do that math right? 2.5 times 1.5 is 3.75. Check my math on that. 3.75. So I take 3.75 and subtract it from 69, and that would have to be 66.25 inches. No, 65.25. So somebody would have had to say I was 65 inches tall to say that was too short for typical. Nobody got anything close. You guys didn't go below 68. So 68 is the lowest value of our data set, but it's not an outlier low by this method. Does that make sense? Now, where was the line in the sand for the top? No, Alicia, ask me that question right now before we go any further. Or was that okay? I thought I saw a question coming. Sometimes I just see things. Okay, too much coffee. That's, I do that too. Too much coffee. What was the line in the sand for the high value? Let's figure that one out too, right? Now we know what the IQR was, 2.5 inches. Increased by 50% is 3.75. Add that to 71.5, and that's going to be 75.5. Did I do that right? 0.25. 75.25. It's this much. It's right here. So when George said 75, you're just barely not an outlier by this method. Does that make sense? You are just barely not an outlier. You're 1/4 of an inch by this method off of being an outlier. Pretty fun, huh? So those are your lines in the sand. Those are your lines in the sand using this method. It sets up a range and it says anything in this range is legit. Anything in this range is not an unusual data point. Is that fair? Is that cool? You guys buy that? Maybe ish.
Is it on sale?
It's well for the cost of tuition, I guess. Divided by 20 for
Are we
today.
gonna have to apply that or,
No. Thank you, Haley, for asking that question. This does it for you automatically.
so we won't?
Look, this shows you where they are. You don't have to actually do that math. I wanted to do the math with you at least this one time to show you where the actual derivation was. And now you have the formula if you ever need it for anything.
Got it.
But the technology will show you the outliers each time. Fair?
Fair.
Good. Very, very good. Well, so far, hanging in there? I got one more data set to do. And we've already mentioned it now.
Your weight.
Guess